In this video, we're going to be talking about lab 3, which is density. And density, as you know, is mass divided by volume. So density is mass divided by volume. Okay. So anything that is matter, which is tangible, it has mass and it has volume. And then when you divide one into the other, you get density. Density is an intrinsic property. That means it is a characteristic of that substance. It can help you to identify the substance, whether that substance is an element or a compound. It also tells you about the purity of that substance. All right. For example, pure water should have a density of 1 gram per mil. That's how you identify pure water. So in case you have a sample of water that does not have a density of 1 gram per mil, then you know that it is impure water. It has other impurities in it. Okay. Now, density is intrinsic in the sense that it's irrespective of the amount of stuff. All right. So irrespective about the amount of the sample size, whether I have pond full of pure water or a fish tank full of pure water or a small teaspoon of water, water is still going to have a density of 1 gram per mil. Okay, so density is able to identify a substance, and it has the mass or volume has no bearing on it, and therefore it is intrinsic because it's not related to the amount of the sample. So in this experiment, we're going to be measuring the densities of two liquids, water and ethanol, and two metals or two solids, aluminum and iron, as well as an unknown metal. So we start out by taking a graduated cylinder to measure out the volumes of those liquids for water and ethanol, and then we will measure the volumes of those metals using the method of water displacement. That means we'll take a certain amount of water, place a certain amount of that metal into the water, and it will displace its volume, and that's how indirectly we will find out the volume of the metal. The masses will be measured using the balance. So in the first experiment, you're going to take a balance, put it on your workbench, clamp the empty graduated cylinder, and record the mass of that empty cylinder in your lab notes. If you're getting a number such as 54 grams, you are doing it correctly. All right. Now, you'll add 10 mils of water to that empty graduated cylinder. So the mass is going to go up because roughly 10 mils of water is going to weigh 10 grams. All right. So the mass should go up by another 10 grams. So if it was originally 54, it would go up to 64. All right. Now you're going to add another portion, another 10 mils of water. So now you have a total of 20 mils of water, and the mass of the cylinder should go up by 20 grams. So if it was originally 54, it should now be around 74. Then you're going to add a third portion of 10 mils of water. So now you have a total of 30 mils of water in your cylinder, and the mass of the cylinder should have gone up to 84 grams. Okay. So then for experiment 2, you're going to do the exact same thing. Clear your bench, take a new graduated cylinder, record the mass. If the original empty cylinder for experiment 1 was 54, this should be the same, around 54. Now to this, you're going to add 10 mils of ethanol. Again, record the mass. You're going to add another second portion of 10 mils of ethanol, record that second mass, and then the third portion of ethanol and record that mass. Okay. So just like you conducted the experiments for water, you're doing the exact same thing with ethanol. In experiment 3, you're going to again zero the balance, take a fresh graduated cylinder, put it on the balance, and add 30 mils of water to it. All right. So if the empty cylinder weighed 54 grams, if you add 30 mils of water, now this cylinder should weigh about 84 grams. All right. 30 plus 54, so about 84 grams. So the initial volume, you will record it as being 30 mils. The initial mass is going to be the 84 grams. Now to this 30 mils of water, you're going to add 5 grams of iron. All right. So if the initial mass was about 84 grams, plus 5 would, it should go up to about 89 grams. All right. And then you'll add another 5 grams of iron. All right. And the volume, of course, will rise because the iron is displacing its volume. So it'll rise up to a little above the 30 mil mark. All right. So note that volume as well. All right. Now you're adding another portion of iron. So now you've added a total of 10 grams of iron. So if the initial mass was 84 grams, with the additional 5, it should go up to uh, if this mass here, 84 plus 5 was 89. All right, you're adding another 5 grams, so a total of 10 grams, so it should go up to about 94 grams. Again, the volume will rise, and so note new volume. So you'll do this a third time, a fourth time, and a fifth time. So you've added a total of 25 grams of iron to that initial volume of 30 mils of water. All right, and each time you're going to record the mass and volume. You're going to repeat this with aluminum. Okay, so be careful, record all your data carefully. Having a notepad, as I said, helps you in case you lose your data. All right. Again, you're going to conduct this fourth experiment with the unknown metal. You'll zero the balance, take another empty cylinder, add 30 mils of water, and again record the mass, which should be again around 84 grams. Now you're going to add 5 grams of that unknown metal 1 and record mass and volume, although in the data table they don't have a spot for this 5 grams of the unknown metal. Instead, they're going directly to 10 grams. So you'll add another 5 grams. So you're now up to 10 grams of the unknown metal. And then you'll record the mass and volume. And you'll do this till you reach 25 grams of the unknown metal. And each time you'll record the mass and volume. All right. So complete your data table, all your short answer questions, and there is a multiple choice segment for this particular lab as well. Okay. All right. I will show you in another video about how to enter the data into the data table, because there's some confusion. In the past, students are unclear about how to enter the data, and I will go over that as well. So I'll let you write the lab write-up, because by now you should be quite familiar on how to write up the lab write-up. As far as aim, your aim is to measure the densities of water, ethanol, aluminum, iron, and then use density to identify your unknown metal. All right. Write up your hypothesis, and then your materials and your procedure. You write down your data, and in your results, explain your data. And then in your conclusions, explain whether your hypothesis was supported or not supported. So what are some of the real life applications of density, all right, especially when it comes to nursing and health? Density is a very useful tool. For example, urine has a specific gravity of between 1 and 1.030. Now, specific gravity is one of um, those units which do not, or one of those quantities that do not have a unit in the terms of density has a unit of grams per mil. Specific gravity is just a number. It's called as a dimensionless measurement because of the fact that it doesn't have units. All right, specific gravity is the density of any substance divided by the density of water, so the units cancel, and therefore it's just a number. All right, so it's very similar to density, except it doesn't have units. As far as the numeric value, density and specific gravity numerically are equivalent. The only difference is density has units of grams per mil, but specific gravity is just the number. Okay? So, if the specific gravity is not in the normal range that is expected between 1 and 1.03 for urine, then it indicates disease. Um, um, it could be some renal disease, or it could indicate some imbalance like dehydration, excessive sweating, and so on. All right. Another way density comes into play health-wise is high density lipoproteins, the HDL, and low density lipoproteins. These are markers of hypertension and heart disease, right? Bone density is important. So you use X-rays to measure the grams of calcium and other bone minerals. And this test will help to determine whether a patient has osteoporosis, where the bones become fragile and are more prone to break up. All right, so these are some of the applications. Again, you can research and find out some other real world applications of density that especially would be useful for you in the field of nursing. All right, so this is the end of this video, and as I said, I will continue on to show you the next video where I'll go over the recording of the data for this experiment.